Hello, I'm Stephen Neshaba, back to give you a little guidance on the pre-lab for the Arrhenius lab that we will be doing next in lab. This pre-lab is all about the Arrhenius plot and Arrhenius theory. The whole idea of Arrhenius theory is that we've looked at the rate constant of a reaction, which I have in this column, as a function of different temperatures, and we will use that information to extract what we call some Arrhenius parameters. The Arrhenius parameters are given in this equation, and it's all based on this idea that the rate constant should depend on the temperature. There's the temperature dependence there. Should depend on the temperature according to this formula. The parameters of that formula are the energy of activation and this constant A called the prefactor or the frequency factor. Normally we take log of both sides of that. We see it makes an equation that looks like, if we called this y, and if we called 1 over tx, then it kind of looks like y is equal to mx plus b. So the slope is m, and equals minus a sub a over r. We solve that for the energy of activation, and this is the third equation then that we'll use to get the energy of activation for this data set. So I'm going to go back to Excel now, and if you're following in Excel, maybe enter in all these numbers here. This table here is just the data that I just showed you, the temperature dependent rate constant data. Okay, we're back, and now first thing we'll do is enter 1 over t. Maybe you've already done it. That equals 1 divided by the t column. Now, of course, it has to be in Kelvin, which we've already done. And, all right, now I'm going to go to the lower right, fill that down. How about the k column, or the log of k? Well, Excel has a built-in function called natural log. Why don't you, and it's ln, just like it looks. So if you want to give that a shot. Okay, here's my attempt, equals natural log ln, open parentheses, and I give it the k box, close parentheses. There's that number. Now I'm going to fill that down using that. Okay, we're almost done. Let's see, I want to make a graph, and to make that graph, I'm going to go to this chart in the scatter plot. And it looks like looks like a nice straight line to me. The numbers on the x-axis, which is 1 over the temperature, are a bit crowded, so I've pulled them apart. And I don't really like these horizontal lines, so I'm going to click on one and get rid of them. Okay, if I think it's a straight line, I can also ask Excel to tell me what the parameters of the straight line are. Do that by clicking on one of the points. Go to chart, add trend line, and here it defaults up to a linear regression. That's fine. I also need to have it show me the equation on the chart, which is what this button is, and as you can see, it just showed up down there. Okay, so now I know y equals mx plus b. M is minus 11,433. So that means the last step here is I want to calculate the energy of activation based on that equation right there. So the minus signs cancel. I just need to multiply by R, and it's convenient here to use the gas constant in kilojoules per mole. So that will be equal to, now the minus of the minus gives me minus 11,433. That's the slope times, oops, I want to cancel the minuses, times the gas constant, 8.314 times 10 to the minus 3. That should do us. Okay, and once you've solved algebraically for the prefactor A, then you can type in a similar equation here, which, as it turns out, will depend on this y-intercept.